These are the solutions for the QuizPrep graphing trigonometric functions handout. Similar to the quiz, there will be no calculator allowed, so I've given some decimal approximations here. The first problem is to graph, and we typically want to graph 2 periods. So we want to graph this function right here. We find that its amplitude is 8. It says -8 here. But remember that 8 is the amplitude. Negative tells us the direction, that it's been reflected over the x-axis. For the period, we take the period of regular sine of the parent function 2 pi, divide it by the frequency, which is 3/2. So we have 2 pi divided by 3/2, which gives us 4/3, which is our period. So on the graph, right at 4/3, I put a dot. And then we divide that dot into fourths, and so we have all of these dots plus the origin of where it starts, and we put the same, the reflection of the dots over the y-axis, so we've got them here. Now, in this problem, we see that the amplitude is 8, which means it's going to go all the way down to -8 and all the way up to +8, and my y-axis doesn't have those, so I needed to change my y-axis. So I erased the numbers that were there, and I counted by 2's, so you can see that we got up to +8 here and down to -8 there. And we're now at a point where we can graph the first period of this this sine function. And I go down and then up, and there is my first period, and there's my second period, and that's 2 periods of this graph. For the second problem, this is where we're going to need those approximations that we had at the top of the handout. I see that I need to figure out the answers for secant, and to do secant, I'm going to be thinking about its parent, which is its reciprocal, which is cosine. We need to first start off by filling out the table up here with all of the different thetas. So I have all my thetas written down. I then am thinking about cosine of each one of those thetas. And so cosine of 0 is 1. And I'm going to go through and figure that out for each one of these thetas here, what the cosine would be. And then I'm going to do the reciprocal for my secants. So I've got all of those, and I even went all the way around and I just did them all up. And now for secant, I'm going to do the reciprocal. So the reciprocal of 1, I'm going to put here, and the reciprocal of 1 is just 1. The reciprocal of √3/2 is 2/√3, and I do all of those. Here's where it gets interesting, which is 0. The reciprocal of 0 is undefined, so I put a u there. I'm going to do the same thing for all of these, all the way up to 0 there, and I have all of its reciprocals, and then I finish out the chart. Now I'm going to go to the first page, and I'm going to fill out all the decimal approximations. So the decimal approximation of 1 is just 1, but 2/√3 we saw on the other page was on the top of the page is 1.15, and etc. But what about at this u? Well, the u is where there's going to be an asymptote. So on this chart, I just put a little dash here to remind myself I'm going to have an asymptote, a vertical asymptote. And then I have all of my other reciprocals and another asymptote. And that would be filling out the chart. Problem number 3 is to do another graphing problem. In this one, we're doing cosecant. To do cosecant, I'm going to be thinking about the graph of sine of 2 theta. So I'm answering these questions really thinking about sine of 2 theta. And the amplitude is 1. The period would be 2 pi divided by the frequency 2, which is pi. So I know that my period is pi and my amplitude is 1. So I'm going to start marking the graph here with those things. I've got my period. I did 1 on the right and I did a negative on the left. I divided into fourths and I have a mirror over there. I put my amplitude on the graph as well. At this point, I'm going to graph not the cosecant function. I'm going to graph the sine function. And so there is the sine function, and I'm putting in all of the places where I would have the asymptotes. And so here's what I've got. But the cosecant is just these black curves. It is not the yellow sine function. It's the black curves and the asymptotes. So we need to get rid of this sine curve, and that's what my final picture should look like. And that is graphing y equals cosecant of 2 theta. For this problem here, we are graphing a cosine. So I'm looking at the amplitude The amplitude is 2. Even though it's got a negative, the amplitude is 2, but we know we're going to go in the negative direction, which just means for cosine, instead of starting up here at the top with the amplitude, we're going to start at the bottom at the negative amplitude. The period, we take the 2 pi and we divide it by our frequency. Our frequency is what we are multiplying theta. We're multiplying it by 1/4, so I'm dividing by 1/4, which is to multiply by 4, which gives me a period of 8 pi. So I put 8 pi over on the right and negative 8 pi on the left. I'm going to divide those into fourths. I'm going to put my amplitude there. And now I'm ready to graph my cosine function. It goes up and down. There's one period of it. And on the other side, there's the other period. So now I have 2 full periods of -2 cosecant of theta over 4. For problem number 5, we're going to graph tangent, and the number in front of tangent is just 1, so my amplitude is 1. It does not stretch or shrink or anything, it's just a standard tangent function. The frequency is 1, and so my period for tangent is just straight up pi, which means between the asymptotes is pi units. And recall that tangent, it had an asymptote at negative pi over 2 and an asymptote at positive pi over 2. But everything is being moved over pi over 2 units. So I'm going to mark where the asymptotes for the parent function would be. This is where the asymptotes of the parent function of tangent would be. And all of these marks where the asymptotes would be are going to get moved pi over 2 units to the right. So I mark those. And then I'm going to mark the asymptotes, and there they are. Those are the new asymptotes. And therefore, now I'm going to just graph my tangent function in each one of these. There's kind of an S curve that goes in each one of those. And there is the graph of tangent. And so I did 4 periods of this, and it just doesn't fit the paper easily. You need to have at least 2 periods, but I just did 4 of them because it looks nice. All right. For the last couple problems, for problem number 6, we've got something going on here. And please notice there's 2 different triangles. There's the large triangle, which happens to be a 30, 60, 90-degree triangle. And then we have an inner smaller triangle. Well, it's a 45, 45, 90-degree triangle. So we're going to use our special ratios. And one of the things we note is that in a 30, 60, 90-degree triangle, we have the fact that there's a short side, which is always opposite the 30 degrees. The hypotenuse is always going to be 2 times the short side. And then the third side is always going to be the short side √3. So we're going to use this to figure out what the short side is. And so by doing the computation right here, we find that the short side is 5√2. And therefore, S√3, meaning the third side, is going to be 5√6. So I'm going to mark 5√6 here. And I need to mark that the short side is 5√2. And if this is 5√2, I'm looking at this 45, 45, 90-degree triangle. And if this side here is 5√2, so is this side. This now allows me to solve for x, because x is the entire length from A to D, take away 5√2. And so x is equal to 5√6 minus 5√2. So we solve for x. Now all we're left with is to solve for y in the 45, 45, 90-degree triangle, remembering that the hypotenuse in a 45, 45, 90 is always the leg, 5√2 times √2. So I do that here, and I see 5√2 times √2 is 5 times 2, which is 10. So that's the length of this side here. For the last 2 problems, this is just a reminder of our exact values of trigonometric functions. I would think a unit circle, draw where -7 pi over 3 is, and you'll notice that it happens to be a clockwise rotation of all the way around, and then a little bit more, another pi over 3 more. And so it's right here, and then we're asking for cosine. Cosine is what value on the x-axis would give me that, and that would be 1/2. For the next problem, -7 pi over 6, we're going to go clockwise also, but this time we're going to just go just past the halfway up to negative 7 pi over 6, and we're asking for sine, which is the y value, and the y value of that is also 1/2. And that's the end of the solutions.